This is Mr. Anderson for Kellogg Community College. We are going to be looking at Section 5 of Chapter 8, Equations Reducible to Quadratics. And what we're going to do is take a look at some pretty challenging looking equations, but actually they actually do some pretty good simplification down to normal quadratics. Apart from the book, I will be using the quadratic formula every single time I can. I will not be using or looking for other techniques like factoring or completing the square since we have done the first three sections of using the quadratic formula and discriminants, I will not be showing all the work of inputting the work into the negative b plus or minus the square root of b squared minus 4ac over 2a. Another disclaimer is that when I check the answers as the homework requires, I will be doing so with the on-screen calculator here, and it is possible that I could make a small typo, so there might be some mistakes or edits in the video. I'll just go ahead and do that. So what I plan on is to do the first 5 problems in the first section, and then do another 4 problems in the second video. Well, let's begin. Alright, so what we're going to do here is look at the 4 steps to solve an equation that's reducible to a quadratic. When you start out with problems in this section, they look real daunting. They look like they're insurmountable, but they're actually not too bad, because the first thing you need to do is look for one variable, to be the square of the other. Look for one variable to be the square of the other. So if you take a look at here, the variable t squared is t to the 4th. So there's the variable we're focusing on right there. And I'll go through these 4 steps in every problem. And then step 2 is to write down the substitutions. So, for example, we will be using u for our substitution, and we're going to then have a u squared, and we'll see why that's the case as we simplify that for the quadratic formula. Now, unlike the book, I'm going to use the quadratic formula no matter what. You may find that factoring might be easier depending on the problem, but since this is the main focus of the chapter, I'm going to basically have you practice the quadratic formula as many times as we can. And then we have to check the answer, because since we are squaring problems, we might be squaring an inconsistency, which means if we're squaring something and the problem wouldn't work, then we might have a problem with the answer. For example, if you have a problem that's like x, or the square root of x is equal to negative 3, that's impossible. But once I square that, it becomes x equals 9, or square both sides. So this is an impossibility that suddenly after squaring becomes possible, and we have to check these answers. So let's get down to business here and go over those 4 steps as we do the problems. You'll also notice that I've kind of wrote these really kind of close together, so I do apologize in advance for the room. You'll have to be very efficient about the way you write your answers here. Moreover, you'll probably want to have a separate sheet of paper if you have bigger handwriting. So our first step is to look for one variable that's the square of the other. Well, in this case, t squared is t to the 4th. So we're going to take our u and set that equal to t squared, and then that would make u squared equal to t to the 4th. Now, what this will do is this will take our problem, instead of with t to the 4th minus 11t squared plus 18 equals 0, now what we have is we have u squared minus 11u plus 18 equals 0. And now we can use the quadratic formula to solve the problem. My a is equal to 1, my b is equal to negative 11, and my c is equal to 18. Now, what this will do is I can plug this into the quadratic formula, so positive 11 plus or minus the square root of b squared minus 4ac over 2a, and this gives me the square root, if you've typed this in correctly, the square root of 49 over 2 times a, which is 2. Now, if I split this up into 2 answers, the 2 answers I get one answer that's 11 plus 7 divided by 2, which is 9. Again, 11 plus square root of 49 is 7. 11 plus 7 is 18, divided by 2 is 9, which is equal to my u. And then I am going to take 11 minus 7, which is 4, divided by 2, which is 2, which is also equal to u. But here's the thing, that's not our answers. Since our u is equal to t squared, we have to kind of go another step here and figure out what we need to do here. So what I'm going to do is take my u, which is equal to 9, but my 9 is also equal to t squared due to the transitive property. So let's kind of think about this for a moment. U is equal to 9, t squared is equal to u, so therefore t squared is equal to 9 because of the transitive property. So my t, if I solve for t, is going to be equal to plus or minus 3 because the square root of 9 is plus or minus 3. Same thing with this one here. My 2 is equal to u, my u is equal to t squared, therefore 2 is equal to t squared, which means I have to take the square root of both sides, so t is equal to plus or minus square root of 2. Now I have to go back and check my answers here, and to do so is going to have me basically lose everything I've written so far, so you may want to write down that the answers are plus and minus 3 and plus or minus square root of 2. So let's go and get the calculator up here on the screen and check my answer. Okay, the first thing I'm going to do is use a lot of parentheses here, and I'm going to check plus 3 first. So I'm going to type in 3 caret to the 4th power minus 11 times 3 squared plus 18. And that gives me, let's see here, that gives me negative 80. Oh, I see what I did. I typed in, instead of caret to the 4, I typed in caret x. I'm sorry about that. So let me change that here, because I know this answer should work out to be 0, and it does. So I checked in my 3, and my 3 works. Now I'm going to check in negative 3. Now I'm going to use the insert command, which is second delete, and that way I can kind of insert until I move the cursor again, second delete, and this also will give me 0. So I've just checked negative 3 and positive 3, and that gives me 0. Well, I've got to check positive square root of 2, so I'm going to go insert square root, whoops, I'm going to insert the square root of 2. Probably would be good. Let's see, I just want to make sure I got my parentheses right here. Let's see, square root of 2 to the 4th power minus 11 times insert square root of 2 squared. I'm a little worried about that first parenthesis here. Let me make sure I put a parenthesis in here as well. Alright, so there we go. Whoa, let me insert that. Okay, so I'm checking the square root of 2, and I know this is right if I hit the answer and get 0, which I do. And now I'm going to try negative square root of 2. And let me insert a negative here, and go and insert a negative here. And I guess as I'm learning how to do this more efficiently, I should be trying the negative values first. That way we get a much better answer here. This is going to be negative square root of 2 squared plus 18 is going to be 0. So I've checked all 4 of my answers, and it works. So all 4 answers are my solution to the problem. Alright, let's do problem 2. So you can kind of see where checking the answers, it could take a little bit of time, but it really is worth it, because sometimes you do run into an inconsistency, like I will with this problem. Okay, step 1 is to look for one variable to be the square of the other. And if you take a look here, I've got a square root of w and a w. So that means if my u is equal to the square root of w, then my u squared is equal to just w. Because if I square both sides here, I get this. So this changes my equation to u squared plus 4 times u minus 12 equals 0. And again, since this is the quadratic formula chapter, I'm just going to use the quadratic formula rather than use factoring. Factoring would work out pretty nicely in this problem, but again, I'm just going to be kind of one-track mind here because I want you to practice the quadratic formula more often. So this is going to be negative b plus or minus the square root of b squared minus 4ac over 2a. Now the discriminant is going to be, in problem 2 here, is going to be 64, and my answer at the denominator is going to be 2 because it's 2 times 1. So this gives me two answers. The first answer, negative 4 plus the square root of 64, or negative 4 plus 8 divided by 2, gives me 2, which is equal to u. And then I'm going to have negative 4 minus 8 divided by 2 gives me negative 6, which is equal to u. Now again, let's rock that transitive property. 2 is equal to u is equal to the square root of w. Then by the transitive property, we're going to have the 2 is equal to the square root of w, which means that I'm going to square both sides, and I'm going to get the answer of w is equal to 4. That's one of my two answers I have to check. And here's the other one I'm going to have to check. I'm going to say negative 6 is equal to u is equal to square root of w. Then by the transitive property, negative 6 is equal to the square root of w. Square both sides, and this gives me 36 is equal to w. Now this, remember what we talked about earlier? This is one of these inconsistencies. There's no way the square root can be a negative number, but still it works out like we should have two answers to this problem, right? Well, let's go to the calculator and verify this. So if we go to the calculator and verify this, and remember our two answers for the problem that we have to check is 36 and 4, well, let's take a look here. I'm going to start off with 4. So 4 plus 4 times the square root of 4 minus 12, and that's going to be 0 as we check it. Now if we go 36 plus 4 times the square root of 36 minus 12, will that give me 0? It won't. So that 36 for my answer is not going to work. So I only have one answer for this problem, and that answer is 4. Alright, let's go to problem 3. And problem 3, let me move the worksheet down here a little bit. Problem number 3, like problem up above, you see I have my u. Whoops, I got to get my pen to work right. Don't want it to just draw rectangles here. I want it to draw what I'm writing. This is going to be u is equal to the square root of r, and u squared is equal to r. So now I can write my equation as u squared minus 2u minus 6 equals 0. Again, quadratic formula, a is equal to 1 because that's the number in front of u squared, b is equal to negative 2, c is equal to negative 6. So it's time to rock the quadratic formula. So we're going to have b plus or minus the square root of b squared minus 4ac over 2a. The discriminant in this case is going to be 28. It's not going to be a perfect rootable number, which is going to cause us some problems here. And that makes 2 times 1, our denominator. So what this means is that I've got to somehow try to simplify this square root of 28, which I can do because the square root of 28 is the same as saying the square root of 4 times the square root of 7. So this is 2 plus or minus 2 square roots of 7. And I'm going to divide each of these terms by 2 since 2 is a monomial. So what this gives me is 1 plus or minus 7. Now 1 plus or minus 7 is equal to u. Oh, sorry, square root of 7. Big difference between 7 and square roots of 7. So 1 plus or minus the square root of 7 is equal to u, which means that I've got now two answers for u. U is either going to be 1 plus the square root of 7, or u is going to be 1 minus the square root of 7. Now, check out what my u is equal to. See, u is equal to square root of r, and u is equal to 1 plus square root of 7. That means the square root of r is equal to 1 plus the square root of 7. Now, that means I've got to square both sides to get my r. And if I do that, my r is fine, but now this is squared. And that means FOIL. So 1 times 1 is 1. Now, obviously, I'm kind of playing with a phantom 1 plus square root of 7 here. So when I do my FOIL, 1 plus 1 is 1. 1 times square root of 7 is square root of 7. 1 times square root of 7 is 2 square roots of 7. And square root of 7 times square root of 7 is going to be 7. So my r is either 8 plus 2 square root of 7. And I have the same thing happen here. You see, I got my r equal to 8 plus 2 square roots of 7, but check this out. Now I have this u is equal to 1 minus square root of 7, which is from my transitive property here. Since u is equal to square root of r and u is equal to this, then the square root of r is equal to this. All right, well, it's time to square both sides. So if I square both sides, this is r, and this is 1 minus square root of 7 quantity squared, so it gives me 2 of them. And again, here comes the FOIL. 1 times 1 is 1. 1 times negative square root of 7 is negative square root of 7. Then another negative square root of 7 is negative 2 square roots of 7. And the square root of 7 and square root of 7 is positive 7. So here I have another answer of 8 plus or minus, or not plus or minus, this is the minus part of it here. I was thinking of the answer, 2 square roots of 7. So now I have an r that's 8 plus 2 square root of 7, and an r that's 8 minus 2 square roots of 7. So these are our two answers. But the question is, do both of these work? Does one of them work? And this is where testing them on the calculator is going to be a little tricky. 8 plus 2 square roots of 7. It's best doing this in parts here. So what this is going to do is just plug that in for this first r, and I'm going to get an answer for that. Then I'm going to minus 2 times the square root of this r. Now that's going to, this 8 plus 2 square root of 7 is going to be inside there, so I'm just going to click the answer button because that's really my 8 plus 2 square root of 7. And then I'm going to go enter, and then minus 6, 0. That's so much easier. That's the way to check that solution. All right, and then now we're going to test using 8 minus 2 square root of square root of 7, like that. All right, so that's for the r, minus 2, and then that answer there for the 8 minus, wait, let me put that, first of all, let me put that in a square root there. Square root of the answer, and then we're going to go get that, and you're going to see it's not equal to 6. So when I subtract the 6, it doesn't give me an answer. So my only answer in problem 3 was not the plus or the minus, it's just the plus. So my answer for problem 3 is 8 plus 2 square root of 7. Pretty tricky, right? Let's go to problem number 4. All right, problem number 4. Now, in this case, I've got an x to the negative 1 power, so that's going to be my u. My u is going to be x to the negative 1 power, and my u squared is going to be x to the negative 2 power, because it's technically the first one squared. So what this gives me, it gives me 2u minus 1u minus 6 equals 0. And again, using my quadratic formula, a equals 2, b equals 1, c equals negative 6. Alright, so with that in mind, what I have now is I'm going to do the quadratic formula. Negative, that 1 was negative, so negative b is positive 1 plus or minus the square root of b squared minus 4ac, which is our discriminant. And I did that on some scratch paper, and I got an answer of 49 divided by 2 times a, which is 2. And believe me, the quadratic formula is a lot faster than tricky trinomial factoring. So this becomes two answers here. 1 plus 7 divided by 2 times 2. 1 plus 7 divided by 4 is going to be 2. And 1 minus 7 divided by 4 is going to be negative 3 halves. So this is my u. So u is equal to 2. U is equal to x to the 1/2 power. So what I have here is 2 is equal to x to the 1/2 power. Now, something to know about x to the 1/2 power. X to the 1/2 power can be written as 1 over x, and 2 can be written as 2 over 1. it is a property that we can flip these two problems, whether you want to see the proof using cross multiplication or not. You're just going to have the answer where x, flipping this on its head to x over 1, is equal to 1/2. So x is going to be equal to 1/2. And again, there are proofs of this in the book, but we can use either cross multiplication to get the x all by itself if you want to see it that way, or just look at the two fractions equal to each other can be flipped on their head that way, or both inverted by taking the inverse of both sides. Now, this -3/2 is equal to u. What this does is I've got -3/2 is equal to x to the -1 power. Again, because of the transitive property. U is equal to -3/2, u is equal to x to the first power. So x to the first power is equal to -3/2. So again, using the inverse property, x is going to be equal to, and again, this is going to be -2/3. It's not going to be a positive. Do not flip the symbol when you flip the problem. So we have to check both of these. So we're going to check 1/2 and we're going to check -2/3. So let's go to our calculator and check it out. Okay, so if we go to the calculator, what we're going to do is go to parentheses. Let's do the 1/2 first here. 1/2 raised to the -2 power minus, again, 1/2 raised to the -1 power minus 6. And making sure that those are negatives, and we have -2, -1, blammo, get 0, and that works out great. Now let's go and check to see if -2/3 works out, and I ignored my own advice, and I should have started with a negative there, so I wouldn't have to, insert. I could just overstrike. So there's -2/3 there instead of -1/2. Let me insert. I hit delete. -2 and then change that to a 3, and that works out well too. So number 4, both answers do work. All right, problem number 5 to finish up this this lengthy part of the video here. Here we have u is equal to t to the 1/3. If you're getting lost as to, I'm not sure what to set the u equal to, it's pretty much going to be the middle term on all of these here. U is going to be equal to t to the 1/3, and then u squared is going to be equal to t to the 2/3, because 2 times 1/3 is 2/3. So that means our problem is going to be u squared minus 2u minus 8. And again, I'm going to use quadratic formula because I want you to get good at using quadratic formula. Even when factoring or doing other forms of solving the problem would be faster. So this is my b plus or minus the square root of b squared minus 4ac, which is the determinant, and that crunches out to 36, divided by 2 times a, which is 2. This gives us 2 answers. 2 plus 6 divided by 2 is 4, which is equal to u. And then 2 minus 6 divided by 2 is equal to -2, which is equal to u. So this 4 is equal to u is equal to t to the 1/3 power. Through the transitive property, we have 4 is equal to t to the 1/3 power. To get the t all by itself, we have to cube both sides, because that's the opposite of the 1/3. So we're going to have t is equal to 4 cubed, which is 64. Here we've got t to the 1/3 is equal to -2. Again, the reasons why: u is equal to t to the 3rd, u is equal to -2 due to the transitive property. T to the 1/3 is equal to 2. Cube both sides. T is equal to -2 times -2 times -2. Careful, is -8. So I have 2 answers to check. I got 64 and -8. So we go to the calculator and we take the calculator out, and let's go type it in. What we're going to have here is the first answer I need to check, which is 64. I want that in parentheses because I'm going to raise that to the 2/3 power. Notice the fraction is also in parentheses. Minus 2 times t, which is 64, raised to the 1/3 power, and then we subtract 8 and get an answer of 0. Then we're going to try the same thing with -8. So I'm going to type in my -8 right there. Type in -8 right there, And if we get 0, they're both answers to the problem. And they are! So thank you for watching, and we're going to have 4 more problems on the next video from the worksheet in this section. Thank you.